Hi, Assalamualaikum. My name is NurulHidayah. I'm the Ahmad Hidzir, and I would like to answer the question from the assignment 3, which is from the FET-DC analysis. So this is the circuit from the question given, and the circuit is a DC analysis circuit. The circuit is also the N-channel DC MOSFET, because we can see the current is flow inside. So therefore it's an N-channel. So if the current is flow inside, it is a P channel. So for the first question is to determine the drain current IDQ, and second question is to determine the DC gate source voltage VDSQ. So for this question, it must answer in a graphical method. So for the first step is to construct the transfer curve table. So this step is to determine the transfer curves based on the value VGS and ID. So by using this formula, which is ID equal to IDSS times 1 minus VGS over VP square. So the value of IDSS and VP is already given in this question. So IDSS equal to 6 milliampere, VP equal to negative 3 volt. So substitute into this value into this formula, and the value of VGS is depends on the value of VP. So VGS will start with 0 and end with the negative 3, because VP is a negative 3 volt. So if the VGS equal to 0 volt, the ID will become 6 milliampere. If VGS equal to negative volts, the ID we get is 2.67 milliampere. If VGS equal to negative volt, ID will become 0.667 milliampere, and if the VGS equal to negative 3 volt, ID will become 0 milliampere. So for the step 2 is to draw the transfer curve. So the value the VGS and the ID in the table, so must plot in the graph. So at the y-axis is the drain current ID in the unit milliampere, and at the x-axis is the DC current source voltage VGS in the unit volts. So just plot the value that calculate before between VGS and ID in the graph. So the transfer curve will become like this. So the step 3 is to find the KVL from the constructed circuit that consists VDS and ID. So based on the circuit given, during DC analysis, the capacitor is open circuited. So the capacitor at the C node and CS will open circuit. So there is no current flow. So it also the capacitor at CI will also open circuited. So the voltage Vs and the resistor 1K is also terminate, because there is no current flow at this part. So as we can see at the circuit is a Thevenin circuit between 10 mega and 110 mega. So at this part, we have to use the RTH. We have to find the value of RTH and VTH. So to find RTH is the 10 mega parallel with 110 mega. So the answer is equal to 9.167 mega ohm. To find the value VTH is a 10 divided by 10 mega plus 110 mega times with the 20 volts. So the value of VTH is equal to 1.667 volt. So after doing the RTH and VTH, we have to redraw back again the circuit like this, and as we know it's an N channel, so the current will flow from drain to the source. So the current will flow from drain to the source, and the circuit will become like this. So to find the value that consists of VGS and ID, we have the loop that has the VGS. So at this loop, we have the VGS between gate and source. So we have to do a KVL method to find the value of VGS. So it will start with the negative 1.667 volt plus 9.167 mega Ig plus VGS plus 750 IS. So we know that IS equal to ID and Ig equal to 0 ampere. So just substitute IS with the ID and Ig with the 0. So when the Ig equal to 0, this will terminate this one. So the equation will become negative 1.667 plus VGS plus 750 ID equal to 0. So we want to find the VGS. So the equation will become VGS equal to 1.667 minus 750 ID. So we don't know what is the ID value. So we have to construct linear graph based on the KVL in step 3. So by using this equation, we have to find the value of ID at the graph. So just take about 3 or 4 points for ID to determine the value of VGS that we want to plot at the graph. So I take if ID equal to 1 milliampere, so the VGSV will become 0.917 volt. If ID equal to 3 milliampere, the VGS equal to negative 0.583 volt. If ID equal to 4 milliampere, the VGS equal to negative 1.333 volt. If ID equal to milliampere, the VGS equal to negative 2.083 volt. So for the step 5 is to draw the linear graph. So based on the graph before, just plot the linear graph at the graph based on the table before that we calculate between VGS and ID. So the linear graph will become like this. Next, to find the VGSQ, the value of VGSQ and the IDQ based on the graph. So we have to find the intersection between the transfer curve and linear graph. So from the graph, the value of VGSQ is a negative 0.8 volt. The value of IDQ is a 3.3 milliampere. For the third question is to determine the drain source voltage VDSQ. So from this circuit, we know that the VDS is between from drain and source. So at this loop, we can use a KVL method to find the value of VDS. It starts with the negative 20 plus 1.8k ID plus VDS plus 750 IS equal to 0. So as we know, IS equal to ID, so just substitute IS with the ID. So negative 20 plus 1.8k ID plus VDS plus 750 ID equal to 0. Simplify the equation, and the equation we get the negative 20 plus VDS plus 2.55k ID equal to 0. So VDS, to find the VDS, negative 20 and 2.55k ID will move to the right, and the VDS will become negative 20 minus 2.55k ID. From the graph, the value of ID is 3.3 milliampere. So just substitute the 3.3 milliampere into the ID. So the value for VDS will become 11.585 volt. So the last question is to determine the terminal voltage Vs and Vd. To find Vd, we have to put virtual voltage Vd at the drain. So at this loop, we can use a KVL method to find the value of Vd. It will start with a negative 20 volt plus 1.8k ID plus Vd equal to 0. So we want to find Vd. So negative 20 plus 1.8k ID will move to the right, and VD equal to 20 minus 1.8k ID. ID is from the graph is 3.3 milli. So VD is equal to 20 minus 1.8k times 3.3 milliampere. So the value for VD is 14.06 volt. So it's same with the VS. To find the VS, we have to put the virtual source at the source, virtual voltage at the source, and at this loop we can use a KVL method. So if you start in negative 750 IS plus VS equal to 0, since IS equal to ID, so it will become negative 750 ID plus VS equal to 0. VS, to find VS, move negative 750 ID to the right, and VS will equal to 750 ID. ID is equal to 3.3 milli. So VS, the value of VS is equal to 750 times 3.3 milli, and the answer we get is 2.475 volt. That's all for me.